Let's take a look at my latest project. This lets you see inside the computer to know how it looks at a number. At the top, you see the number in human-friendly form. In this case, 3.5. And here you see the bits that the computer would usually use to store this. You can click on them too, it's all interactive. In fact, this whole experience is made to be interactive. Feel free to pause this at any time and just try it yourself. This is the double format that's very popular on computers. If you see a number with a decimal point in it, it's probably a double. More details, of course. Lots of links. Well, it's meant to be explored. What's this blue thing? Well, first thing is apparently the negative or positive sign. This next thing here that's in kind of a reddish brown is called the exponent. Again, you can read about what it actually does, or you can just try it. Let's say I make the exponent bigger. Well, we went from 3.5 to 7. We doubled it. Here, let me do that again. So 3.5 goes to 7, and this thing over here, basically the decimal point just moved. I don't know, do you call that the binary point? So, down here is a number that I kind of built myself. Just an internal look. It's similar to this, you can see them, but this is kind of meant to be the number. It has a decimal point, it has a negative sign, oops, positive sign. Let's see what happens here. Just to the right of the decimal point. So that one is apparently a half. And if I click here, apparently that's a quarter. An eighth. And of course you can add them together. It's binary, it's just kind of backwards. Instead of 2, 4, 8, 16, it's half, quarter, eighth, 16th. Down here I made it so you can enter any number you want. So well, there's probably better ways to do that, but this is what pi looks like under the hood. There's some examples down here. Ooh, nan, not a number. So that's like 0 divided by 0. So it would print it on the screen as nan, and internally it's in this special format here. The exponent is all ones. It's that largest possible value we can fit. If we try to get bigger, we wrap all the way around to this tiny number, 308 zeros before the first number. So 0.308 zeros, then 112. So a tiny number. Or we can go the other way. Whoops. So if we go down, now we're at a really big number. So 2046 is the biggest exponent, and 2047 is kind of a special case that's for nan and infinity. So yeah, this is just a somewhat artificial, someone just decided that this was the way to show infinity. And of course there's a negative infinity and a positive infinity. And just as well, there's a negative and positive 0. Hey, I didn't invent this stuff. I'm just showing off what's out there. I don't know if you noticed, this was usually a 1. And you see I can't click on it to change it. Yeah, let's go back to... So here, and for most things, this red number was a 1. And that's kind of hiding inside of this red number here, this reddish-brownish number. You can read the details again. I'm not trying to explain this format. I'm just trying to let you see it yourself and try things. Here, so what happens if I go into here, and instead of saying equals to, or enter is the same as equals, I'm going to say, I don't know, add to. It's just a convenient way to try things. What if I want to keep dividing by 2? And again, the green parts don't really change. It's just the exponent, because we're dividing by 2. These are kind of unusual if you don't know, if you're not familiar with JavaScript. These last 3 will convert the number into an integer before it does anything. And yeah, so these are all, again, described down here. This was just quick ways to try things. Of course, you can also set individual bits. But you can, these are the 2 interfaces. You can see the bits and change the bits. This is the sort of thing a programmer might see all the time. Where did that 0004 come from? Well, it's a round-off error, and the last bit is wrong. Down here, we're changing things, though, in a slightly more human form. We're saying stuff like, whoops, hey, we lost that round-off error. I didn't do that on purpose, but that 1 bit just went away because we needed more bits for the integer part. So let me say divide by 2. And yeah, we lost it. Let me try that one more time. Set that last bit to 1. And over here, 1, 0, that's binary for 2. That's going to become 1, 0, 0, binary for 4. And now I'm just going to add 2. And again, by adding 2, and it added an extra 0 here, and it took 1 off the end, and it just, well, it went back where it was supposed to go. That bit just never existed. Let's see a more confusing, well, it was confusing when I first saw it. Let's start with the number 3, and let's change that to a third. Well, you learned this in kindergarten, maybe. A third is 0.33333 and goes off as far as you can. That's in human numbers. In computer, well, in binary, 1/3 is 0.010101 as many times as you can, and if I had more precision, I'd have more 0 1s. And this is a real thing that happened to me. Well, not just me. I've been out on Google, and a lot of people have these questions. Sometimes you have to use a different format temporarily, and you go down to 32 bits, and then when you come back, what happened? Well, this human form of the number, it just looks really ugly. The first half is correct. The second half is garbage. And ideally, well, for one thing, maybe it just wouldn't show me all that. Maybe it would just show me the part that's correct. But let's understand what's going on. These look random. Well, what's going on here? It just added all these digits that it didn't have for a second. Maybe it went off to your GPU or your database or someplace where bits were more expensive. It all got, well, they weren't just zeroed, it was rounded. You can see here 0, 1, 0, 1, and then it ends with a 1, not a 0, 1. Just like 2/3 is 0.666667. Here's that one little thing in the last place. So this is why, again, this looks really ugly and it's unfortunate, but this is why it's happening, and at least I can see what's going on. What else? So we looked at negative infinity, min safe integer, max safe integer, and the only difference is this negative sign. And you see what's going on here. Every one of those green digits is in use all the way to the decimal point, and there's certainly no room for anything smaller. Like if I said plus a quarter, that would definitely, it just doesn't do anything. In fact, I just added like 10 quarters, and they got lost in the ether, lost in the bit bucket, because they're too small to represent. There's no extra zeros here to use that. If I had a half, that might actually do something. Might round. Rounding is complicated. I'm not even going to touch that, but whoops. And what just happened? Our exponent got a little bit bigger. And our, what happened here? We have this black 0. Again, I can't do anything to that. I can't touch it like this one. Here we are. I'm on the very last digit, the place that was way off in the noise before. And now that's 2. Every time I click on this, it goes between 4 and 2. And again, the ones digit is just gone. Guess we can keep doing that. So now, again, we're drawing a bigger number up here, but we're not really more precise. These numbers, the green ones, are real. They really could be something different, in this case a 4. But all this, it's just a placeholder. You really don't get any precision at this point. And again, if I tried to add a 1, it would just get lost in the bit bucket, in the ether, whatever. So that's why they call these the max safe integer and the min safe integer. Once you get beyond these values, you can't use normal integer math. Just the things you expect to work don't work anymore. Epsilon. So it's 16 digits in normal English, normal base 10, 0.16 zeros and a 2, or 15 zeros, or something close to that. And why is this important? This is that last bit. Here, let me add 1 to this, and then you'll see the magic. So again, we started with epsilon and we added 1. And here we are. We've seen this before, the 1.002. How many are there anyway? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, about 16 digits. That's what I thought. Okay, so this is where we were before. That last little bit that I said this is the smallest I can add to it. The technical term for that is epsilon. Most of these things will work in any programming language. I've only seen the max safe integer in JavaScript, but most of this is built into the hardware and very standard. So yeah, those are the special values. You can add more if you want. Explore as much as you like. That was the point of this. If If you just want to learn the format, there's other people who've done stuff. Wikipedia is maybe a little too detailed, but I'm sure there's other people with... I mean, this format hadn't changed in over 30 years, so you've got options galore. But I suggest you just play with this, and then you'll understand how computers see numbers. Thank you for watching. Like, share, and subscribe.